equations. That's basically this whole chapter. In these next three sections, we're going to use tables, graphs, and equations. And in this section alone, we're going to talk about how to solve a system using tables and how to solve a system using graphs. This will come later. This will actually be 3.2. All right, I got a lot of examples in this. So I think what I'm going to do is a lot of these I'm going to solve for y. I will do that piece very fast, hopefully to save us just a smidgen of time because I think it's going to get a little long. Here we go. The first one wants us to solve a system of equations by making a table. I am going to do that on the graphing calculator, but in order to get them into the graphing calculator, we need to solve for y. So this first equation will be y equals 3 minus x. In this equation, I will have y equals negative 6 plus 2x. All right. So what I'm going to do is go to my graphing calculator. Let me get my little thing up here. Yeah, this is saving us all kinds of time, isn't it? Here we go. I type in y equals 3 minus x into my graphing calculator. Let me zoom in just a little bit. And then I also type into y2. Notice how it says y sub 2. I type in negative 6 plus 2x. All right, instead of graphing, we're going to go to our table. And you see how this says, oh, you can't see it, but this is the button spot. It's in yellow or blue, depending on your calculator, above the graph button. So second graph puts us to our tables. This is the x value. Instead of having two separate tables like this, they're just using this x value once, and then you look down the y column. So y1 has numbers like 3, 2, 1, 0, negative 1, so on and so forth. Well, y2 has these particular numbers. What you're going to do is look down the columns until you find matching y values. The x value that goes with that is 3. So keeping that in mind, 3, 0 is your solution to the system. Let me get that off of there. All right. So the solution to the system using a table is 3, 0. Whoa, that's kind of funky. Let me try that one more time. 3, 0. Okay, what that means is if I put this x value in here, 3 minus 3 is 0. It works in this equation. And I go ahead and try 3 and put it in here. 3 times 2 is 6. 6 plus negative 6 is 0. So it works in this one as well. So this is one point that works in both equations. So it's called a solution to a system. Example 2. Tell me this is not the same one. All right, look kind of similar, a little too similar to me. Y equals 2 minus x. And then I have, oh, here we go, I got to do a little work. Negative 3y is equal to negative 6 minus x. Divide each piece by negative 3. Okay, so we have y equals 2. Negative over negative is positive. I'm going to write that as 1/3 x. So go back to my graphing calculator. I've got y equals 2 minus x. Y equals 2 minus x. And then because I can't remember for anything for the life of me, the other one is 2 plus 1/3 x. So 2 plus 1/3, taking 1 divided by 3. I'm putting parentheses just to be safe. All right, and then I go to look at my table. Second graph. All right, oh my gosh, how lucky am I? Right away, bing, 0 matches with 2 and 2. Okay, so my solution to this system is 0, 2. 0, 2. All right, and you can check your work again. If you put a 0 in here for x, 2 minus 0 is 2, so my y value is 2. So it checks out in this one. I'm going to go down to this, or you can go back to the original if you'd like. Put 0 in for x. 0 times 1/3 is 0. 0 plus 2 is 2. That's this value. So it works in both equations, so this is my solution to my system. Now, I probably should have started with the graphical ones. The graphing way to solve a system because I think it's more visual. I think it helps you see a little more clearly what you're looking at, what you're looking for in a solution. All right, so each one of these, now you guys, you can do 0 blank blank 0 for each one of these just because they're in standard form. You have that option. I'm one of those people that like slope-intercept form. I would switch, okay? Partially because sometimes it goes through 0, 0, and sometimes we have problems with that. So the first one, I'm going to solve for y. Subtracted x from both sides. Divide everything by -2. So I have negative x over -2, but we don't write it like that. We write positive 1/2 x. Okay, that's my green one. My blue is this one right here. So I'm going to solve for y, 6 minus x. It's just my thing. Okay, y equals 6 minus x. 1, 2, 3, 4, 5, 6. Ooh, I'm almost off the graph. That's okay. I'm going to stick with it. Slope is -1. Rise -1. Run +1. Rise -1. Run 1. There I go. And I graph this line. Oh, now I go back to my green. Graph my green equation. Y equals 1/2 x. My y-intercept, it's not there. Oh, that's right, it's 0. I put that right there. My slope is 1/2, rise 1, run 2. You can use like stars and hearts. Okay, maybe not that much. I do X's and dots here just so I can tell the difference between the two if I don't have colored pencils or markers or colored whatever. Oh, this one's very nice. This one works out really beautifully. It comes into an intersection right there. That is the solution to your system. That is the only spot in the whole wide world where it will answer both this equation and this equation correctly. What's the coordinate? It's 4, 2. Okay, I'm not even going to check my work on that. We're going to go on to example 4. Solve a system by graphing. Once again, I'm going to go ahead, and this is another reason why I'm not using standard form. If you put 0 blank, you're going to have 7/3. All right, so I'm going to solve for y. X plus 3y equals 7. I'm going to subtract x. Going kind of quick. 3y is equal to 7 minus x. Divide every, oh look, and I got the 7/3 anyway. 7/3 minus 1/3 x. Not pretty, but I'll do that in red. 7/3 is actually 2 and 1/3. So I'm going to go up 2 squares and 1/3 of a square. I'm going to subtract of slope. My slope is -1/3. So I rise -1, run 3. Rise -1. Notice how I'm only going down to the third below it, and run 3. Okay, I can go up the other way and then go back, -3. All right, and then I'm going to go ahead and make a line. I could probably get out my straight line. Ooh, ooh, oh my. How lovely is that? All right, let's go purple with this other one. Oh, this should be much better. Negative y is equal to 3 minus x. Got to solve for y, not negative y. I have y equals -3 plus x. So now my y-intercept is -3, and I am going to have a slope of 1. So I rise 1, run 1. Rise 1, run 1. Oh, look at this. I think that's supposed to cross right there. Ooh, looks like it does. This point, are you kidding me, is 4, 1. Is that my answer on the other one? Seriously. 4, 2 was the other answer. Okay, well, it wasn't quite the same. Let's move on. Example 5. All right, a service club is selling copies of their holiday cookbook to raise funds for a project. The printer's setup charge is $200 and each book costs $2 to print. The cookbooks will sell for $6 each. How many cookbooks must the member sell before they make a profit? So let's go ahead. Their expense, these are their expenses. They have $200. You're going to have to pay $200 just to say, hey, I want you to make a cookbook. And every cookbook is going to cost $2, and you have no idea how many cookbooks are going to be printed off at this point. The cookbooks will sell, so this is going to be the money that is going to be coming in, as my husband would say, income coming in. So you have 6x. And I want to know when these are the same, okay? Because it says, how many cookbooks must the member sell before they make a profit? Like when you break even, when you're no longer losing money, when you're starting to say, hey, we're making money, yippee-yi-ki-yay. Here's what we're going to do. We're going to go to our graphing calculators again. 200 plus 2x. So let me get the screen up here. Y equals 200 plus 2x. And then my other equation, before I forget, is y equals 6x. Okay, 200 is a y-intercept, and this has a y-intercept of 0. So that's my y values. We're going to have to fiddle. This is, I don't know. Sometimes the best thing you can do with the window is just fiddle with it. We're going to go from 0, because we're not going to have negative numbers. We're going to say up to, we'll go 100 to start with. X scale, count by ones. Y minimum, 0. Y max, remember what was that number again? Oh, 600. So I'm going to have to go at least to 600, and I am probably going to go a little bit higher. And we can count by 20, sounds good. Let's see what kind of graph we got. Oh, lovely. That just so happened to work out just wonderfully. All right, so we want to find this spot right here. Here's the method. I'm having a moment of like, here we go. What did I press? I pressed second and trace because it gets me that calc button up above. It's either in yellow or blue on your calculator, generally. So you go second, trace. It gets a screen like this. I see intersect, which is number 5. The fastest way, press number 5. First curve. Doesn't matter which one I'm on. I'm just going to call it this line. The second curve, I'm going to make sure I'm on the other line. And then my guess, I get as close to that intersection as possible. And they say the intersection is 5,300. 5,300. Now let's talk about what that means in our problem. Okay, 5,300. That means 50 of these, that's how many cookbooks, and you come out with $300 is like your cost or your income, that's when you're going to break even. So let's check. 50 times 2 is 100. 100 plus 200 is 300. Check down here. 50 times 6, so you're going to sell 50 cookbooks, $6 a cookbook, you're going to get $300. When you did 300s here, this is what you were spending. These two amounts, yes, spend, this is your income. That's when you start breaking a profit. So if you can sell 300 or more cookbooks, then you're making money. Example 6, a student government is selling candy bars. It costs $1 for each candy bar plus $60 setup fee. The group will sell the candy bars for $2.50 each. How many do they need to sell to break even? So let's do the cost. $1 for each candy bar plus $60 setup fee. So $60, it doesn't matter how many candy bars, you're going to be out this much plus 1x. All right, the group will sell the candy bars for $2.50. So $2.50 per each. All right, and we want to find out when this number, when your cost is equal to your income, and then you call it profit. So 60 plus 1x. Here we go again. Go back, clear it out. 60 plus 1x. And then the other one was, I think, 250x. Let me do a quick double check. 2.5x. Okay, this is my y-intercept is 60. This one has a y-intercept of 0. So here I go. I'm going to go down here and just, we're going to make this 100. Okay, you may have to pause. I'm going to quick graph and see if I can see the intersection. Barely. I do not need this much of my screen, so my x max, I want to get rid of some of my x max. Let's not do 100. Let's do half of that. Okay. Still, this intersection is to the very top of my screen. I would love to see more of this, so I'm going to do my y max a little bit bigger. So y max, let's do twice as big. Okay, there's my intersection. How do we do that again? Second trace, go to 5, the intersection. I'm on this line. Now, second curve, I think it generally jumps around for you. Your guess, you actually don't have to get all that close. And it gives me 4,100. 4,100. That means 40 candy bars sold, you're going to get $100, or for 40 candy bars is going to cost you $100. This is your break-even point. Okay, moving on. Okay. These are the words you're going to have to know when you apply to each situation. I hope to do a little thing in class to help reinforce this. Consistent and independent. Draw a picture like this in your notes. Get that down. You're going to have to study that. Consistent and dependent. And this is inconsistent. These never intersect. You never have a solution. So that's why we call them inconsistent. This is consistent and dependent. This is a horrible example, but I'm going to give it anyway. Oftentimes there is kind of a stereotype that girls need a buddy to go with to the bathroom. They're dependent on their friend. Oh, dependent. This one line is right on top of the other line. And consistent and independent, one person goes this way, another person goes that way. You're independent. You don't need anybody to hang around with to go do whatever you need to go do or say or go shopping or whatever it has to be. All right, graph the system of equations and describe it as consistent, independent, consistent and dependent, or inconsistent. I'm not going to graph on graph paper. We're going to go to our calculators. So, first equation, negative y equals 5 minus x, y equals negative 5 plus x. All right, that's one of them. The other one, x plus 2y is equal to negative 4. 2y is equal to negative 4 minus x. Divide everything by 2. So y is equal to negative 2 minus 1/2 x. All right, we go to our calculators. Negative 5 plus x. I can only remember one at a time. Negative 5 plus x. Of course, this is like my fourth example here, but plot 1 should actually be off there. All right, make sure it's negative and not a subtraction sign. And the other one is negative 2 minus 1/2 x. Negative 2 minus 1/2 x. Look what I did. I did the 0.5. All right, I think I'm going to go zoom. That's that button right there. I'm going to go down to 6 because that's what we call a standard window. It's like negative 10 to 10, negative 10 to 10. I love this one for graphs like this. Okay, let's find that intersection. We could trace along, but I'm going to go second trace. Number 5. First curve, second curve, and I'm going to be daring and not get that close to the intersection. They tell me the intersection is 2, negative 3. 2, negative 3. That means that if I put 2 in here, I'll get negative 3, which I do. If I put 2 in over here, I get 1. Oh yeah, I get negative 3 over here. That means I have one solution. Oh, I guess I missed the point of this. I found the solution, but what is it? This is going to be consistent and independent because I've got one graph going one way, the other graph going the other way, and there's my intersection. Okay, example 8. Ooh, look at that. I'm going to start here with negative 6y is equal to negative 6 minus 9x. Divide everything by negative 6. So now I have y equals positive 1 plus, I'm going to reduce this to 3/2 x. On this one, I have 6x minus 4y equals negative 4. Negative 4y equals negative 4 minus 6x. Divide by negative 4, divide by negative 4, divide by negative 4. Y equals 1 plus 3/2 x. Holy cow! Look at that, you guys. 1 plus 3/2 x, 1 plus 3/2 x. I bet you're not nearly as excited about that as I appear to be at that particular moment. But I don't even know if I have to show you the graph of this. 1 plus 3/2 x. 1 plus, putting that in parentheses, 3/2 x. And the other one is 1 plus 3/2 x. What do you think is going to happen? Oh, I bet you didn't know. You're going to have one graph out and the other one is going to graph out on top of that. Did you know you could do this funky thing? I'm going to show you where the other one's going to go. Yeah, let's do that. The first one graphs, the second one is graphing right on top of the first one. What's the whole point of me showing you some of this? My whole point is to find out, is it consistent and independent, consistent and dependent, or inconsistent altogether? Well, it's consistent because you have a solution. You have lots and lots of solutions. Every single point on that line that's graphing there, oops, every single one is a solution. So you're going to have an infinite number of solutions, and it's dependent. Like this line says, come with me, I'm going to go to Target. Come join me. Dependent. All right, example 9. I'm going to solve for y here. Negative 6y is equal to 0 minus 15x. Divide by negative 6, divide by negative 6, divide by negative 6. Y equals 0. Let me reduce. That's going to be positive. Divided by 3 is 5 halves x. Then I've got this one. 5x minus 2y is equal to 10. Subtract 5x from both sides. 10 minus 5x. Divide by negative 2, divide by negative 2, divide by negative 2. Negative 5 plus 5 halves x. Okay, now you're like, they don't even look the same. They're going to graph out something different. What are we looking at now? So I go to my graphic calculator and I type in 5 halves x. 5 divided by 2x, and then I have, I think it was negative 5. Oh, negative 5 plus 5 halves x plus 5 divided by 2x. How dark is that getting as I'm leaning over? Well, I think you can still see that. All right, we're going to graph that. There's one line. There's the other line. They are parallel. They are never going to intersect. So what's my answer to this? These are inconsistent. They are inconsistent. You will never have a solution to that system. If you try to graph and solve, if you try to go to your table and look at that, later when we get to equations, you will never find a solution. We call that inconsistent. And that is the end of our lesson for today.